Good day everyone, I am Ariel Joseph De Leon and together with my group, we will educate you on how to analyze beam, truss, and frames using SP Frame and Safe. So let's start. Auto input, we'll write project beam, then school PLM, then engineer De Leon. So structure type 2D frame since the beam is only 2D. Then change the units to metric. Length is in meter. Section millimeter, area millimeter squared. Modulus of elasticity kilonewton millimeter squared. And point load kilonewton. Moment load kilonewton meter. Distributed load kilonewton per meter. Axial kilonewton, moment kilonewton meter. Click OK. Default since we'll leave it as is since there are no given parameters. Then next is the material. So we'll select concrete materials for the beam. Density is 24 kilonewton per cubic millimeter. Modulus of elasticity is 24,870. Resistance ratio is 0.17, and since there will be no thermal expansion, thermal coefficient is equal to 0. Then add, click OK. Then geometry. Label will be the beam. Sectional area, since we'll select the type first, rectangular, and the dimension will be 250 by 250 since there are no parameters given. So click add. Okay, and prismatic members. Since there are no prismatic members, we'll just skip this part. Next, load. So, since there is a left triangular load, so we'll put left triangle, and intensity is negative 12. Distance from J1, 0, then the length is 1 for the whole beam, and orientation global y-axis. Click add. Then next, right triangle. Intensity is still the same, 12, and the orientation is the same, so add. Next is the distributed load of 15 kilonewton. So distributed load, negative 15 kilonewton, and click add. So that's all for the loads. Next is the load cases. So exterior loads, then click add. Then we'll add the other loads such as the left triangle, right triangle, distributed load, 15, add, and okay. So next, okay. So we'll include all these 4 except for self-load since it will be analyzed in the problem. So include, then add. So click OK. From joint 1, 0, 0. Joint 2 is 4.5. Joint 3 is 9. Joint 4 is 13.5. Joint 5 is 15.5. 17.5. 18.5. 21.5. 22.5. And add. And okay. So joint list. Fixities. Since there is a hinge support on joint 1, we'll click the dx and dy, then add. Then for rollers, we'll only check the dy. So join 2, add, join 3, add, join 4, add, then joint 9, add. So we'll close first the this, since we need to show where the nodes are. So click preferences, joints, label, member labels, click cities. So next is auto input. Back to the auto input page. So there are no incline supports, spring supports. So member 1 to 2, 2 to 3, 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, and okay. So next is member types. So we'll use material, concrete, section type beam, then select all, then click add. Okay. So next is partial release. There are no partial release in this problem, so we'll not use it. Partial corrections, none. Rigid offset, rigid end offsets, none. Rigid diaphragm, none. Member group, none. So joint loads. So there are joint loads in members 5, 7, 7 and 8. We'll put negative 10 kilonewton and a negative 6 kilonewton meter moment on the node 5. Click add. The next, there's negative 15 in node 7. Click add. Then negative 20 in node 8. Add. Okay. Then member loads include load case, left triangle, load list, left triangle include in member 1. Then modify, and X right triangle include for member 2 and add. Then next is distributed 15 include on member 3, add. So next is known displacement. Since there are no displacements in this problem, so skip. Self-load, none, and solve the problem. To show the results, go to the analyze and support reactions and change the format to 1.4G right. 12.4G right, and the results are this.
Hi, I'm Daniel Lau, and I will be introducing the software SAFE. SAFE is used for the design of slabs and foundation systems of a structure. So first, open your SAFE software and then click the file button and then new model, and then check if the unit is on currently US, and then choose the grid only, and then assign the value of 6 for the grid line on the X direction and 7 for the Y direction. The grid spacing for X is 20 and for Y direction is 18. So we will edit the grid. Pick the spacing button above, and then we will change the spacing of the grid A and grid D to 26 and 27. On the Y grid data, we will change the spacing of 3 and 4 to 24, both 24, and then click OK. Then the model will be created. After we have created the model, we will edit the view of the model. So click the view and then the set display options, and then uncheck the horizon box to remove the excess grid lines. Then click OK. So after we modify the view, we will now define the materials. First the slab properties, and then we will modify the slab 1. We will change the thickness to 10 inches and then click OK. And we will add another slab property. We will name it as drop, DROP, and then we will change the type to drop and then the thickness to 16 inches, and then click OK, then OK, and we will now define the other property, the beam property. We will modify the beam 1. We will change the shape type to L beam, and then the web width at top and web width at bottom to 18 inches, the depth as 24 inches, the range width as 5 feet. As we can notice, we input directly 5 feet. We can do that because SAFE converts automatically the units. So it is converted to 60 inches and then the slab depth to 10 inches. And then click OK. And then OK, we will now define the column properties. So we will modify column 1, and then we will check the include automatic rigid zone and then automatic drop panel. The parallel to 2 axis is 18 inches and to 3 axis is 18 inches also. And then the drop panel parallel to 2 axis is 72 inches. Parallel to 3 axis is 72 inches also. And then click OK, and we will add another property for the column. We will name the property as column no drop, which means this column has no drop panel. We will change the parallel to 2 axis and to 3 axis to 18 inches, and then click the automatic rigid zone area only, and then click OK. Then after, we will now define the wall properties. So modify wall 1 and then click the automatic rigid zone area over wall, and then click OK, then OK, and then we will define the load patterns, and it is automatically defined. There is a dead load and live load, and for the load cases we will check only if it is linear static. So it is linear static, so click OK. After the load cases, we will now draw our members. So first thing that we will do is to edit the snap options and uncheck the intelligent snaps, and then remove the 0.25 from the snap increments, and then click OK. And then we will now draw the slab. So as we draw the slab, we will click from grid A7 to F7 and F7 to F1, and then F1 to D1 and D1 to D3 and D3 to A3, and then click enter. So the slab is created. After the slab, click escape, press escape, and then click the slab, and then click the edit button and then edit areas, expand or shrink areas to 9 inches. So the area expanded, and then after it expanded, we will now draw the columns. So the first column that we will draw is column 1. So change the property below to column 1. So we will highlight the intersection where we will put the column 1. So it is from A6 down up to E3, and we will also include the D2 up to E1. So we will also put column 1 here in this part, and after we put the property of column 1, we will now put the column node wrap to the perimeter wall. So there you can see that there is no drop panel. Then click enter. After you click enter, we will delete this 4 column because we will put an opening in here. So we will draw walls now from C6 down until we measure 30 feet. So we will measure 30 feet and then click enter. Yes, 30 feet. Then click escape and then draw again wall from C6 to D5, and then draw another 30 feet wall down and then click enter. After we draw the walls in its position, we will now put opening, and we will now put the beams first on the perimeter, only on the sides of A to F and then 1 to 7. Then click enter after we added the beams. After the beams, we will now put the opening to the wall that we put. So type of object, opening, and then drag from the corner of C6 to the opposite corner, and then click enter. There will be an opening. After we add an opening, edit, and then we will now add the design strip. So add design strip from X and design strip for Y. Y and strip layer B. Then click OK. After adding the design strip for both X and Y direction, we will now assign load data, surface loads, and then we will add dead load, which is 30 pound per foot squared. Then add to existing loads, then click OK. After that, click the assign and then assign tab and then clear display of assigns, so we can add another load. And then the assign load data surface loads, we will now assign live load, which is 50 pound per square foot. Add to existing loads and then click OK. After we add dead loads and live loads, we will now analyze our model. So click run and analyze, then it will automatically ask for you to save your file and then save it. For the design basis, we will use the finite element base in the direction 1 bottom bar and then click OK. So it will generate the results for bottom bars, and then click run, and then we will now run detailing. This will take a few seconds. So after the detailing, the Model Explorer will generate the drawing sheets. So from there, you can view the beam rebar, the beam framing plans, the schedules of beams. So there you can see all the drawings there with the template already. So after you view the details, save your file and then create report. So after viewing the details, we will now save our file, and then from the file button, click the create report, and then it will be asked to save for the report name, and then we will name it as save tutorial. So after saving the report, a Word file will be opened, and there you will see the report that the SAFE software generated. You will see all the data and the results from the analysis and the detailing. So there the loads and the results. So that's it for the SAFE tutorial, and hope you learned something. Thank you.
So good day everyone, I will now show you how to analyze a 2D truss using SP-Frame. So first, let's open the SP-Frame program and let us save first our sample. Yes, as truss, then save. Okay. Then we have here the menu bar, the access, define, process, analyze, show, and options and help. So to make it easier, let us use the auto input. For the structure type, 2D truss, project, truss, and engineer, just write your name. Okay. For the units, let us use the metric system. Then these are the units. Click OK. For the defaults, nothing needs to be changed. So just click OK. For the materials, label concrete. Density is 24. Modulus of elasticity is 24,870. For the Poisson's ratio, 0.17. And for the thermal coefficient is 0. Add and click OK. For the geometry, type is rectangular. For the label, just type section. Width and depth is 500 by 500. And then add and OK. For the loads, we'll be not using this since the given is joint loads. So just click OK. For the load cases, just add external. Click add and OK. Then for the load combinations, click the external, include, then add, then click OK again. For the joints, type the joints of the truss. Okay. We have here the following. So as shown, then click OK. For the fixities, at joint 1, since it is a hinge support, click the X and DY, then add. At joint 3, roller, joint 9, roller, click DY, add, and OK. Incline supports, just click OK, OK. Then for the members, first, let us close this and go to show menu. Click preferences, check joint, label, member labels, fix this, click OK. So that we can now see the joint nodes. Then go to process, members, then connect all the joints. So now we already have our truss. We already connected all the joints and created our members. So now let us check all our inputs. Okay. Since we already have it all, we are now going to add member types. Select concrete section, then select all the member list. Then click add and OK. For the elevation, just select OK. Then member group, just click OK. For the joint loads, joint 1, let us put 6 kilonewtons. Then at joint 11 is negative 27 kilonewtons. At joint 12, negative 30 kilonewtons. Joint 14, 15, and 16, it has a load of 50 kilonewtons that is perpendicular to the truss. Members 13 to 9 to 13. So we will put for the fx negative 23.287 and for fy negative 44.246. After this, just click OK. So after we have all our joints, let us now go to show load diagrams. point loads, distributed loads, check this. Then factor 0.05 so that we can now see our loops. So there we have let us now analyze. Click solve, then close. Then to show the support reaction, select analyze again, default 2.4 right, then there you have it. We already have our reactions. So thank you for watching.